Hello everyone, myself is Shahrukh Khan from St. Xavier's Senior Secondary School, Hardoi. Today I am again here with a new video of class 10th physics of chapter magnetic effects of electric current. So, before coming to the point, I would like to remind you all kindly subscribe our school channel and click bell icon on mobile for further notification. Okay, in this chapter, come to the point. In this chapter, I will tell you about the two topics, that is force on a current carrying conductor and Fleming's left hand rule. Okay, so what is force on a current carrying conductor in a magnetic field? First, I would like to tell you what is the magnetic effects of electric current. Actually, magnetic effect of current is, as we all know, that whenever a current flowing in a wire produces magnetic field around it, which gives the magnetic effect of current. This effect was discovered by Oersted in 1820. How he discovered it? A current carrying wire was able to deflect a magnetic needle. Since a magnetic needle can be deflected only by a magnetic field, then he concluded a current carrying conductor always gives rise to a magnetic field around it. So this is called the magnetic effect of current. The magnetic effect of current is also known as electromagnetism. Electromagnetism means electricity, the electricity which is produced from magnetism, or we can say electricity produces from magnetism. Simply we can say an electric current produces a magnetic field around it. Okay, so this is the magnetic effect. Now come to the main point, that is force on a current carrying conductor in a magnetic field. As all we know that an electric current flows through a conductor produces a magnetic field. The field so produced exert a force on a magnet. The field so produced exert a force on a magnet. Magnet is placed in the vicinity of the conductor. So this is suggested by and Mary Ampere, that the magnet must also exert an equal and opposite force on a current carrying conductor. In 1821, Michael Faraday was one of the scientists of physics that he discovered that some mechanical force is experienced by a current carrying conductor when the conductor is kept in a magnetic field, and this force acting on the conductor can make the conductor move. Thus simply we can say that magnetism affects electric current, and this is called motor principle. This is called motor principle. So whenever the electric current that an electric current carrying wire exerts a force on a nearby magnet, the field of the magnet will interact with the field generated by the electric current to deflect it perpendicular to the wire. The reverse, sorry, that if an electric current exerts a force on a magnet, then by Newton's third law, the magnet must exert an equal and opposite force on the electric current. This was suggested by also the scientist Andy Mary Ampere. Okay, now the resultant force can cause either the wire or the magnet to move thereby, converting electrical energy into mechanical energy. Okay, so the movement of the conductor in a magnetic field is due to the electric current flowing through it. Students, as you know that an electric current carrying conductor has a magnetic field around it. This magnetic field and magnetic field of the magnet affect each other. It makes the conductor move perpendicular to the direction of the magnetic field. Okay, this can be understood by taking an activity we can do. Let us consider that a conductor which is suspended with the help of insulated copper wires between the poles of U-shaped magnet. Then close the switch, which we can see in the diagram. If we close the switch and observe the conductor in its electric current, the electric current has a clockwise direction. Then we can observe the direction in which the conductor moves. Now, reversing the direction of the electric current, if we reverse the direction of the electric current, as we can see in the diagram, what direction does the conductor take now? Or we can say what happens to the conductor when no current is allowed to flow. From this activity, we observe that on reversing the direction of current in the conductor, the magnetic force reverses its direction. However, no force is experienced, that is, current does not flow in the circuit. Thus, we can say that the direction of force over the conductor gets reversed when there is a change takes place in the direction of electric current. Means, if the direction of electric current changes, then the direction of force on the conductor will also be changed, that is, will be reversed. Okay, so students, when the direction of current is at right angle to the magnetic field, that is perpendicular to the magnetic field, then the magnitude of force will be highest. This is the condition. The direction of force experienced by a straight conductor carrying current and placed perpendicular to a uniform magnetic field can be obtained by using Fleming's left hand rule. Now students, here are some points which we have to remember. That is, a current carrying conductor does not experience any force due to its own field around it. Means, if the conductor has its own field, then it will not experience any force due to its own field. The second point we can remember that a current carrying conductor does not experience any force if kept parallel to the magnetic field. Means, if the conductor we have kept parallel to the magnetic field, this means the current carrying conductor will not experience any types of force. Okay, and as I have told you that whenever a current carrying conductor experiences maximum force when placed perpendicular to the magnetic field. Okay, and you all know about the magnetic field, that is what is magnetic field. So what is uniform magnetic field? A magnetic field is said to be uniform when a unit north pole placed at any point in the field experiences the same force. Means, whenever unit north pole will be placed at any point in the field will experience the same force, then the magnetic field is said to be uniform. Okay, now we can consider that a straight conductor of length L, which is carrying current I placed perpendicular to a magnetic field strength B, then the maximum force F experienced is given by F is equal to BIL, where F is the force, B is the magnetic field of strength, I the flowing current, and L the length of the conductor. Okay, thus we can write F is equal to BIL. This is the formula of force which is experienced by a straight conductor of length carrying current I, which is placed perpendicular to a magnetic field. Okay, so now what is the unit of magnetic field strength, or we can say V, unit of V. So from this formula, the formula is F is equal to BIL. From this formula we can find the value of V. V will be F is equal to F upon IL. Okay, so as we know that the SI unit of force is Newton, and current is the SI unit of current is ampere, and length is in meter. Thus the thus B will be measured in Newton per meter ampere. Okay, so this 1 Newton per ampere meter of magnetic field strength is called 1 Tesla, and the Tesla is represented by the capital T. Thus we can write 1 Tesla is equal to 1 Newton upon ampere meter. Okay, so a smaller unit of magnetic field strength is Gauss, and 1 Gauss is equal to 10 की power minus 4 Tesla. Okay, now students, there is a question raised that on which factors the force acting on a current carrying conductor depends. Okay, so there is three factors on which the current carrying conductor depends. From the formula we can find out the factors, that is F is equal to BIL. So first, the magnitude of force acting on a current carrying conductor placed in a magnetic field is directly proportional. Magnetic field is directly proportional to current flowing through the conductor. That is, force is directly proportional to I. F is directly proportional to I. So students, more the strength of current flowing through the conductor, then more is the force experienced by the conductor. Means if the strength of current flowing through the conductor will be higher, then the force experienced by the conductor will also be higher. Second one is force is directly proportional to strength of magnetic field. Means to say, if the field is stronger, then the force will also be stronger. If the field is stronger, then the force will be more. Third one is force is also directly proportional to the length of the conductor. Okay, longer the conductor in the magnetic field, more is the force experienced by the conductor. Means if the conductor is largest, the force will be highest. Okay, I hope you all students got about the force on a current carrying conductor placed in a magnetic field. Now next one is that, as I had told you, that how will you find the direction of force experienced by a straight conductor carrying current which is placed perpendicular to a uniform magnetic field. Okay, so that the direction of force experienced by a straight current carrying conductor can be obtained by using Fleming's left hand rule. Okay, now what is Fleming's left hand rule? This rule states that if we stretch our palm and we stretch the thumb like this, that the thumb, forefinger and middle finger of your left hand such that they are mutually perpendicular to each other, then when they are mutually perpendicular to each other, then the first finger will point in the direction of magnetic field, and the second finger gives the direction of current. When and the first finger points in the direction of magnetic field and the second finger in the direction of current, then the thumb will give the direction of force, or will point in the direction of motion, or the force acting on the conductor. This is the Fleming's left hand rule. Like this we can see the example that how we have to stretch our left hand. How we have to stretch our left hand, that is, thumb will be straight and first finger will also be straight, that is vertical and horizontal we can say. Okay, and third one is this. Thus we can say in the figure that is giving thumb is giving the motion, the direction of motion, that is the direction of force. And field is field is directed by first finger, and second finger giving the giving the electric current. Okay, thus we can say we can stretch our left hand in such direction so that we can find out the direction of force or direction of motion of conductor. Okay, so this is Fleming's left hand rule. This is Fleming's left hand rule. Okay, now I am going to discuss about the question. My first question is, when is the force experienced by a current carrying conductor placed in a magnetic field largest? In this video I have explained about this, so students, I hope you will reply it. The second question is, a conductor carrying a current experiences a force when it is placed in a magnetic field even though the conductor is not moving. How does this come about? Okay, and third one is, how does a current carrying wire move when placed in a magnetic field? So these are the questions, and my one question is also there. First question, last question, that is, does force act on a current carrying conductor when it is kept parallel to the magnetic field? It is also explained that I have told you that remember these points, in this there will be answer. Okay, so I hope you all got about it. Thank you.